How you doing, class? This is a live screencast. Mr. Bensing's first ever live screencast in front of a class. Here to take a look at worksheet 5.2. I'm going to start off in the beginning. We're just going to review some of the stuff that we've had before as far as like electronegativity. I think that was, what, 4.3 or something like that. No, 4.4, the second part of 4.4. Electronegativity values generally, and as we go from top to bottom, the value decreases. There we go. As we go from top to bottom, and as we go from left to right, the value for electronegativity increases. Let's just take a quick second to remember what electronegativity is. Electronegativity is the amount of pull an atom has on an electron, like an outside electron. It can pull, atoms can pull electrons in. That value is called electronegativity. Metals tend to have low electronegativities because they want to get rid of electrons, not take them in. But nonmetals tend to have high values for electronegativity. So using your table above, find the electronegativity difference for each substance. The table above is the next screen I'm going to show you. And then click which bonds are present. Now here's the key. If it's a metal and a nonmetal, we're automatically going to call it ionic. We're not going to worry about the range of, remember, if we go from 0 to 0 to 0.4, that is called nonpolar covalent. If we go from 0.4 to 1.7, that is called polar covalent. And if we have a metal and a nonmetal, we're automatically calling it ionic no matter what. So let's continue on. Excuse me. This is, I just uploaded a similar picture of a periodic table. The reason why I'm using a periodic table with electronegativities, you see this is the electronegativity for hydrogen, is so that we can show that aside from hydrogen being on the left-hand side, most nonmetals are on the right-hand side above the stair-step line in red, and then all the rest of those elements to the left of the stair-step line would be metals then. And that's how we're going to use to identify for an ionic bond where we have a metal and a nonmetal bonded together. So let's take a look. This says for the substance I2, that means that I have I bonded to iodine bonded to iodine. And because it's the same, and this iodine is, if we would take just a quick look back, iodine is over here in the nonmetals, which means that I have a covalent bond because there's no metal there. So this is going to be a covalent bond, and because whatever the value is of I, I'm going to subtract it from itself, so the value could be like 2.1 minus 2.1 is always going to equal 0, so this is definitely a nonpolar bond. So the electronegativity difference, let's see what the actual electronegativity is. So for iodine, the electronegativity is 2.5, so I should change that example here to show you what it actually is, which is 2.5 minus 2.5 equals 0. And if it's 0, it's nonpolar. Remember, nonpolar goes from 0 to 0.4. Polar goes from 0.4 to 1.7. Okay? So that helps us determine that. Now, here I have PCl3. PCl3, I have what looks like two nonmetals. I have phosphorus right here and Cl right here. 2.1 for phosphorus and 3.0 for chlorine. So that means I'm going to just simply subtract whatever I get here then is going to be 0.9. So this is going to be covalent again because there are no metals. But this one falls in range of polar. So I check off the polar. Okay? Do you guys see how I'm doing that? Are there any questions so far? Okay. So again, silicon and oxygen. So I go back to my periodic table. Silicon and oxygen, 1.8 and 3.5. I just take the larger number and subtract it, 3.5 minus 1.8. And whatever I get there is going to be larger than 0.4. So I know I have a covalent, and I know it's going to be polar. Can you keep that there for a second? I can. So what does that actually equal? What was that, like one?
You really have Dr. teacher's handwriting.
I know. What can you say?
I don't know. Was it always like that in high school?
I'm getting criticized. Chicken scratch and hieroglyphics are what a teacher described my handwriting as, yes. So it's been like that for a long time.
Wow.
Thank you, Michael Gillen, in the audience.
My handwriting is decent. Not anymore. It used to. I don't know how it could like get worse over time, but it did.
So, just let's take a look at one that's definitely going to be ionic, which means that I'm pulling from both sides. If I take a look at this one right here, I have Na and Cl, so I go back. There's my Na, firmly in the metals category, and my Cl is firmly in the non-metals. So that means I don't have to do anything here, nothing here. It's automatically an ionic bond, and I don't have to check any other boxes. So I just recognize that I have a metal connected to a non-metal, and that is enough for an ionic check mark. Okay, this should not take very long at all. Okay, I'm going to skip ahead. I'm going to skip ahead to the next part. The next part looks like this. Indicate which atom will have the positive charge and which one will have the negative charge in the following polar bonds. Okay, so what I do typically, almost always, I take a look. I know that 2.1 is for hydrogen and 3.0 is for chlorine. If you're not sure about that, I go back to the table. 2.1 for hydrogen, I already circled it. And 3.0 for chlorine, I circled that one also. The one that's more electronegative is the one that's going to get the minus charge, and the one that's less electronegative is going to get the positive charge. So indicate which atom will have a positive charge and which will have a negative charge in the following polar bonds. So I'm going to do a +1 for hydrogen, -1 for chlorine. It works out to be like this for pretty much all of them. 4.0, so this is going to be the +1, this is going to be the -1. Oh, let's take a look at sulfur. I know automatically that fluorine is still 4.0 and is going to be the more electronegative. But let's go back to sulfur and see what it is. Sulfur is right here at 2.5. So at 2.5, I'm still going to have the negative for fluorine and the positive, for sulfur. It doesn't matter whether it's a +1 or a +2 or whatever. And again, 3.5 for oxygen. And let's see what nitrogen is. Nitrogen might be like 2.8 or something like that. Nitrogen is 3.0. So 3.5 for oxygen, 3.0 for nitrogen. So which one would I make negative? I would make the oxygen negative. And then I'd make the nitrogen positive. Now, the other questions that are on the back of this page, they are absolutely directly from your notes for 5.2 Ed Puzzle. So I'm not going to go through there and answer all of those questions. And yes, I do want you to answer the rest of these that I left blank here. Okay? Following exactly the same instructions that I did. Any questions? All right, that's it. Good luck. I hope you do well.